All right, welcome to this Exam 2 review. In this first problem, we'll be dealing with a Poisson probability distribution. So suppose that a mall kiosk has customers arrive at an average rate of 4 customers every 10 minutes. And we are tasked with calculating the following probabilities. Now, it might be good to just review a few things first about the Poisson probability distribution. So we're dealing with a distribution for a variable that is essentially a discrete variable. Remember, discrete means it can take on values 0, 1, 2, 3, 4, and so on. Now, the mean that we could have for a Poisson probability distribution could be like, 4.5 or 4.6 or something, as you'll see in the table in the back of the book. And that's table 7. I think that's on page 782 in the back of the book. And one of the assumptions that we use in a Poisson probability distribution is that all of these discrete probabilities can be added together if we're trying to find a particular range in which the value x could take. And because we're finding a range, we can add all of these probabilities together because they are independent. So that is key for us in a Poisson probability distribution. So just to also as a matter of review, remember that the probability for any given value of x in this distribution to be equal to little x, this is going to be equal to the mu, or the mean, to the power of x times e to the power of negative mu all over x factorial. And of course, x factorial here, just as a matter of review, you should know this at this point, but suppose you had something like 4 factorial, that would equal 1 times 2 times 3 times 4. Or 5 factorial would be 5 times 4 times 3 times 2 times 1. Okay, something like that. So these are just some examples. So let's go ahead and tackle that first part, part A. We're asked, what is the probability that x is greater than 6? Okay, now in a Poisson probability distribution, we could have lots of values greater than 6, perhaps. And you'll see actually in the table in the back of the book, we could have anywhere from ranges of values ranging from 0 to 14. The reason it doesn't include anything beyond 14 is because those probabilities are so small. So in this case, we need to recall that this is going to be equal to the probability of 1 minus, and then in brackets here, the probability that x is equal to 5, plus the probability that x is equal to 4, plus the probability that x is equal to 3, plus the probability that x is equal to 2, plus the probability that x is equal to 1, plus the probability that x equals 0. We could have 0 customers perhaps come through in a time interval of 10 minutes. And so this is the easiest way for us to calculate this probability. And just know that I'm getting these probabilities from the back of the book in that table, and they are as follows. Probability that x is equal to 5 here. Oh, I actually forgot one. Excuse me. Also the probability plus the probability that x could equal 6, right? Very important that we include that, because the probability that we're trying to find is that that x is greater than 6. So we need to include everything from 0 to 6 in this bracket. So the probability, I'll start with this one. The probability that x is equal to 6 is 0.1042, plus the probability that x is equal to 5, 0.1563, and so on. I'll go ahead and add all of these probabilities. One, 4, 6, 5 plus 0.0733 plus 0.0183. Okay, so that should be 7 probabilities added together. Okay, great. And all of this together is equal to 1 minus 0.8894, which is approximately equal to 0.1106. And I also plugged this into a calculator just to double check the work, and I got the following result. Just a point here on the exam, if you were to put 0.1106 or 0.1107, you'd get the credit either way. So if you're using the probabilities from the back of the book and adding them together, this is what you will get. Okay, so let's jump to the next part here. Part B, the probability that x is less than 2. So in this case, we can just add the probability that x is equal to 0 plus the probability that x is equal to 1. And these probabilities, respectively, are 0.0183 plus 0.0733, and this is approximately equal to 0.0916. And again, I plugged it into a calculator here just to double check the work, and this is what I got. So again, you see that this rounds to the same thing. So that's nice. All right, now let's look at part C, the probability that x is equal to 10, but in a span or a time interval of 20 minutes. What is the probability that exactly 10 customers arrive in the queue over the next 20 minutes? So in this case, one of the nice things about the Poisson probability distribution is that you can make linear adjustments here. So now instead of our mu equaling 4 customers every 10 minutes, we can say that mu is equal to 8 customers every 20 minutes. And so the probability that we're working with here is calculated. It's probability that x equals 10, which is equal to 8 to the power of 10 times mu to the negative 8 over 10 factorial, which is approximately equal to 0.09926, or you could round that to 0.0993. Notice, however, that when we make these linear adjustments to our mean, that this probability would not be equal to, so in other words, 8 to the power of 10 times mu to the power of negative 8 over 10 factorial. It's not equal to 4 to the power of 5 times mu to the negative 4 over 5 factorial. These are not equal. So we cannot assume that the probability that 10 customers arrive in a span of 20 minutes is equal to the probability that 5 customers arrive in the span of 10 minutes. So just an important clarification there for you. Okay, the last part, part D, is asking what's the probability that x falls in this range? In other words, that anywhere from 3 to 6 customers walk in and arrive at our queue. Notice that this is equal to the probability that x is greater than 2 or less than 7, right? Because we're going to include all of the same probabilities. Probability that x equals 3 plus the probability that x equals 4 plus the probability that x equals 5 plus the probability that x equals 6. And when we add these together, it's 0.1954 plus 0.1954 plus 0.1563 plus 0.1042. Again, those probabilities taken from the table in the back of the book, table 7, and this is approximately equal to 0.6513, or in a calculator, 0.651223, and so on. So again, just to be clear, if you were to put 0.6513 or 0.6512 in as your answer on the exam, both of those would be correct. Okay, so that wraps up Poisson probability distributions, or our review of Poisson probability distributions, rather, and I'll pause it here and get the next question ready for review.